Hey everybody, so I'm back on that penetrator HB-1000. Apparently I didn't test it long enough because I sent it back to the guy and he went to fire it up and he got nothing. He got a transformer hum, 22 volts across here and nothing else. Surprising to me because I had LEDs and all that stuff, so I was at a loss. So I started going through the board again, and I even replaced the chip. Again, I had a spare, but I actually checked the chip out of circuit, like compared it to the new one, and they checked out the same, so the chip wasn't the issue. So then I started looking at the different uses for those chips. That's the chip that's in there, UA723, same as an LM723. And what I found was that the circuit was actually pretty standard. Here's just a quick little drawing I did of a couple things I wanted to verify. In the data sheet I went through, they called for higher value resistors to set this to 12.8 volts, but I did the math, and with the 7 volts from the reference it made sense. So the only thing I came back to was either the capacitor setting the frequency, this one was bad, or the inverting input in plus here, because in the circuit in minus and current sensor hooked together, I'm sorry, reference and non-inverting, so 6 and 5 are hooked together, so those two are connected. Inverting negative input is the one that gets the feedback from the output from pin 10. If you follow that there. So what I wasn't getting was I wasn't getting any signal on the inverting input. So I followed that back, and the inverting input is fed off of the base drive of the transistor. Something was pulling that down. I had checked this transistor. This transistor, tip 3055, standard, nothing fancy. It checked out at the time, but after I checked it a few more times, it started to check weird, and then it checked bad. This was the other problem. Makes sense, because the original chip, the base leg burned off, but I thought, that was something to do with the capacitors, or, who knows. So, I don't have any tip 3055s. I thought I had some, I don't, but what I do have are 2N 3055s. So I soldered this one in. You can see some of the solder marks on there, and worked beautifully. Everything came right on, nice and good. So what I'm going to do is I'm actually going to mount this tip 3055 to the heatsink right here, and then we'll remount the board with a 3050 tip with a 2N 3055. It'll be essentially like this with a little jumper wire to the 24 volt input or 22 volt input. So to do that safely, I was thinking about trying to reuse the mica. This is another one. I was looking at different mounting methods. I could use the mica like this. That will separate it enough, but those edges make me a little nervous. So instead, I think what I'm going to do is I have some of the more modern, that silicone heat shrink material. So I think what we're going to do is essentially this, wrap that around, maybe wrap it around, but at least have it cover the entire side. So to do that, I need to make this fit on here. So one way I can do that is literally just kind of push the legs through, and I think that's the best way to go about this. And then we have 2 holes. So I'll show you. Got that hole. Oh, didn't quite push through. There we go. So there's the 2 holes. There's our protection. So now what I'll do, just to make it look a little nicer, we'll Okay. Now I'm cutting it a little larger on the lower side, just a little bit, because that will be against the heatsink. And then I have to pop a hole through here, which, how do I want to do that? Screwdriver? Drill bit maybe? Oh, screwdriver seems to do it. Yeah, there we go. And then the screw, actually I'll use the same screw because that does have a insulation washer. There we go. So that's going to get installed and then soldered into the board. We'll install it first. Oh, let me get some heatsink paste. Alright, let's clean that old stuff off. Clean that off. One modification I made was I added an actual ground bonding wire because this was just grounding through that pin there. And now we have an actual ground wire, so it's better. Alright, so that's clean. Now let's see, what's the easiest way to hold this so I can put it on this way. Use my faux stubby, pretend stubby. There we go. Damn it, I can't can't rotate it. There we go, I got it to start. That's the hardest part. And without having you know, a good view, because I need to shut up. No, that didn't work. Alright, let's try that again. Actually, I'm going to get this started and then I'll be back. Alright, let's try this view. Maybe you guys will be able to see and I'll be able to work and we can be in harmony. I thought about taking that board, taking that aluminum piece out or loosening it, and I may do that. I'm just really trying not to take apart any more than I have to, if that makes sense. My fingers are blocking the light, so I can't see if I'm lining up with the hole. Let's get a flashlight.
Eternity later.
Alright, now it's started. Let's see, can I put just adding that little piece makes this shorty work a lot better. So let's see. Alright, getting there. Might have to pull that plate out to really get this thing snug. Yeah, you know what? I don't want to take a chance and screw it up. So let me find a nut driver I can loosen those fasteners up with. Alright, so those are not coming out. That one's no problem, but the other one, those relays are in the way. So just gonna have to do it by hand, and it's just gonna take me a little longer than I want it to. Let's see, is that a... This tip is a little thicker, so it might be easier. And the only job of this mount is to act as a heat sink. There's no electrical connection to that transistor through here, which you'll see. We'll check it. We're gonna verify that with the meter. Just want to get that all the way down. It's pretty snug. We'll just get it the rest of the way. Oops. There we go. Alright, now we can mount the board. Alright, so check this out. This is how the board is going to mount. Screw goes through over here, and then the base and the emitter pins almost line up perfectly. I'll have to shift them just a tiny bit. Just a little up. A little up and to the side, and then they line up beautifully just like that, and we'll solder those. I'll add the jumper, you'll see, and then we're golden. So let me get the mounting screw that goes through this guy. We'll spin it. Let's see, you guys got a good view, good enough view, hopefully. So it's just weird though, because last time, or first time I worked on this, I thought I ran it long enough, but I didn't, obviously, because it wasn't quite right. But the owner was really cool about it, and real nice guy too, like I've said before. Alright, so let's tighten up that front screw. Use my little stubby to start it. Put my head in front of the camera. Come on, there we go. There we are. And then, yep, those all line up nicely. You can see those down there, that's good. Alright, let's go solder. Alright, so let's do the emitter. And the base. Get those nice and soldered, not too much, but not too little. That's good. Then we get our, up here, the reason I'm doing this is we need to tie the collector to the 22 volt input. So we do that, and then I'll get the jumper that I pre-made. And I thought about attaching this with a nut and a bolt, but let's be honest, solder is way better. And that is fed through here. So I'm actually going to, I was going to just solder it right to the pad, but instead let's use the holes that the designers created. Oh, come on. There we go. Oh, of course. There we are, like that. Just bend it down to hold it in place so I can get some solder on it. We'll tin it and then solder it. There we go. So I am happy with that. I think that looks good. That will work good. My ground wire is here. Dress that a little nicer. Actually, I may shorten this wire a little. Have it coming all the way over to here. If I shorten it to there, it'll lay a bit cleaner. Oh, you guys can't see. All right, so here, so we are grounded already. I really don't even need to deal with this wire now, but just to, you know, so that I know I have a good bond, let's put this one here, and let me get the tweezers so I don't burn myself. Alright, that looks good. I'm happy with that. So that's good, that's good. Let's tighten. Let me just give those screws holding this board, or screw, one more little. There we go. Not going anywhere. And then underneath those two pins, I think we'll slide some transformer tape under there just to extra level of protection. I mean, as long as that board doesn't move, nothing should happen with those. But do this without making a mess. I really should have done that before I put it on, huh? It's funny what you see in retrospect. Come on. All right. Come on. There we go. And the whole reason I'm doing this is just to protect those two lower pins. I don't expect that stuff to come off or move, or I don't expect, you know, those wires to, those legs to move, but this way, if they do, there's nothing to worry about. Let's see if I could maybe stick it down this way. I guess I could just cut it. Let's do that. Let's just... So I had my fingers all over that, and that'll be good. So I'm happy with that. That'll keep those pins if anything shifts. Alright, let's go power it up. Alright, there we go. This is a cool amp. To power... Oops, I'm gonna have to get rid of that. The old... what do you call it? Mica thing. I do want to wipe the top of that transformer off. Yeah, I think we are in good shape here. Get any of my tape or my silicone fingers off the front too, and the back. Looking good, looking good. So anyway, what I began to say is this is a good amp. It is built very interestingly. It actually has two power supplies. So 110 volts comes in and then goes to this switch. And then once that switch is turned on, this power transformer is energized. Then we have a center tap, I believe, going to the positive. And then the two outer going to a half wave rectifier. That's what this is. It's two diodes pointing to ground, but I had it drawn out somewhere, but it's a half wave rectifier to ground. So then that gives us 22 volts DC out of the capacitor if we go across here. That then splits. We have two 22 volt wires coming out. One feeds the first power supply that drives the power for the radio. This gives you 12.8 volts to run your mobile unit hooked onto it. The other thing it does is it feeds this brown wire here, which I believe is the relay control, or for, you know, the coil on the relay. So that's all this is doing, is running your radio and I believe running the coils on the relays. The other 22 volt DC line off of this capacitor goes to this power supply over here. We have some bigger cans down there, some 2N3055s. Curious. So that's also running a pair of these, and then that power supply is for the linear. So this has a 2-chip or a 2-transistor MRF454 from Motorola. It says 636 under them. I don't know what date code that is. I'm pretty sure this was built around 1976. All of the parts I'm pulling out have date codes of 75 or so. This has, come on, focus. You can see it right there. A7551. So my guess is the second to the last week of December, maybe right before Christmas, that transistor was made. And everything else in here is like 75 or 76, it looks like, date wise. The chip, the original UA723, says 7273 on the one side, and then M7628 on the other side, upper right hand corner. So my guess is 1976. So this whole amp was probably made in 76 is my guess. So it's a year older than me, maybe, roughly. So it's a cool design. So that power is just for the linear. So even if this crapped out, you could theoretically change a few things so that it would still work off just that power supply. You just wouldn't be able to run your radio off of the same unit. So yeah, so it's plugged in. Let's turn it on and see if we get our oh, actually, let me show you guys the pilot light. That was the other thing I had to fix. The socket for the pilot light right there was cracked and wasn't sitting straight inside of the inside of things. There we go, you can see it better. So I made sure the bulb was snug, uses a incandescent twist-in bulb, and then some heat shrink, and that should hold it really well. So again, let's rotate it back. I do have this plugged into a dim bulb tester to kind of just protect me, or protect it, not really protect me, I'm fine. But just in case something was really wrong. Now it's, you know, it's on the DVT. So, nothing. Crap. What did I forget? What did I forget? Did I get base and collector backwards? I don't think so. Maybe I did though. Maybe I have base and collector reversed. Yep. Dang it. Base and emitter. Because of the height, base emitter. So I have base and emitter flipped the way I have them wired. So I got to do a little more creative wiring. Stand by. Right. So there's the change. I have heat shrink over it. Now the legs are protected with heat shrink. So I'm going to go hit that with the heat gun real quick, and then we'll power it up. So now, go to DC here. Now, let's see if we get anything out of this. Let's get on the, let me get on this output here. Can I? There we are. That should hold those in place, so we should get lights and voltage. There we are, 13.2. I like it. We've got our lights on the front. Okay, so that's a receive relay. We have our sideband that holds the relay on. We got our pilot light, 13.2 volts. Very good. So now what I'm going to do is I'm going to take it home. Oh, and by the way, that transistor, I got my finger on it nice and cool. I'm going to take it home. I'm going to put the top on real quick. I'm going to take it home and hook it up to my radio rig and make sure it does all its stuff. So yeah, next time if I work on something like this, I'm going to be extra careful on checking these old tip 3055s. So that'll do it. Alright, if there's no clips after this, then we can call this good. So, you know, as always, thank you for watching.